Pharma Chemistry Academy YouTube channel. This is my sixth video of stereochemistry topic. So the topic is Meso compounds. Meso compound is defined as optically inactive compound has similar to chiral centers. It's a stereoisomer compound superimposable on mirror image known as meso compound. So this meso compound is optically inactive compound which has similar chiral center and its stereoisomer compound is superimposable on mirror image is known as meso compound. The example we taken for explanation of the meso compound is tartaric acid. The IUPAC name of tartaric acid is 2,3 dihydroxy 1,4 dicarboxylic acid. So at 1 and 4 positions carboxylic acids are present. At second and third position hydroxyl 2 hydroxyl groups are present. So this C2 and C3 in this tartaric acid is similar chiral compound. Because why it is similar? So I am written the Fisher projection for the tartaric acid. So first carbon, this is second, third and fourth carbon. So the second carbon and third carbon. So second carbon and third carbon are similar chiral center. So chiral center is which is attached to four different groups. So at the second carbon, carboxylic acid and hydrogen and hydroxyl group is present, and this one is the one group for this second chiral center. So in third carbon, so the groups are similar what are present to the second chiral carbon. So that's why these 2 and 3 are similar chiral centers. So in the third chiral center hydroxyl group and hydrogen carboxylic acid. So whatever the groups are present in the third chiral center, those are present on the second chiral center. So that's why second and third carbons in this tartaric acid are chiral center. So this tartaric acid is the optically inactive, so which has the two similar chiral center and its stereoisomer. So stereoisomer means rearrange of atoms or groups in a compound forms the its corresponding stereoisomer, so which is superimposable on mirror image, so that is meso compound. So we discuss. So for this is the first structure of the tartaric acid. So I form the mirror image for this compound. So when I place a mirror in front of here, so at the second carbon the hydroxyl group is come closer the mirror, hydrogen goes far. So next at third carbon hydrogen come closer and the hydroxyl group is far from the mirror, carboxylic acid. So this is the second form of tartaric acid. So now what I do is I rearrange the groups at the third carbon of first form of tartaric acid. So I return the carboxylic acid as easily. At the second carbon I return same. At third carbon I left side of third carbon I write hydrogen and right side I write hydroxyl group. So I rearrange the positions of these groups at third carbon and carboxylic acid. So next I return the mirror image for this stereoisomer of tartaric acid. So carboxylic acid and OH and H. So I take this stereoisomer of first tartaric acid
and another one
so
is
in this one, so what will happen? So it is an stereoisomer of the first tartaric acid, which is the third form of tartaric acid. So it is optically inactive because so these are the similar chiral centers. So when I draw a imaginary line in the half of this molecule, so on plane of symmetry of this molecule, plane of symmetry, when I cut the molecule in this plane, so in this plane, so after cutting of this molecule, so when I place the mirror here, so on mirror image of off part of the molecule is superimposable exactly as like of half of the compound. Half of the this half of the compound is superimposable with the second half of the molecule. So that's why this stereoisomer on mirror image superimposable to each other. So that's why this is the mesotartaric acid. Mesotartaric acid. Similarly, in the fourth form, so this is the stereoisomer of the tartaric acid. So when I draw a plane of symmetry, imaginary line in this plane, so after that when I place a mirror, the half of this part is exactly superimposable on mirror image. So that's why this is fourth form is also mesotartaric acid. In Latin language, the meso means, in Latin language, meso means middle. Meso means middle. So when the compound is on middle part undergoes POS, plane of symmetry, half of the part of the molecule is superimposable with the half of the part of the molecule on mirror image, even though have the similar chiral centers. So that compound is known as meso compound. So in this one, in this fourth one, another reason for the meso character of this stereoisomer is, if this carbon rotates the plane polarized light towards the right side, those that is dextro rotation, and other chiral center, similar chiral center, rotates the ppl light in equally and opposite direction. So equal and opposite direction, so levo rotation can be caused. So similar compound rotates the ppl light equally but in opposite direction, makes the compound optically inactive. So equal and opposite rotation by the half of the part of the molecule makes the compound rotation cancel to each other and makes it optically inactive. In this molecule, the one chiral center rotates the ppl light towards the right side, and another chiral molecule rotates the ppl light left side. So two chiral center rotates the ppl light equal and opposite direction of a molecule, so makes the compound inactive. So that concept is known as the internal compensation, so makes the meso compound optically inactive.